The answer to this question is true. You can only make a type 2 error, which is a false negative error, when the null hypothesis is false. The correct answer is B. Statistical power is the probability of getting a statistically significant result when the null hypothesis is false. Statistical power is the probability of detecting a real effect or rejecting a null hypothesis when you should. Out of the options that we have for this question, the only element that does not increase statistical power is increasing the significance level from 0.05 to 0.01. It is harder to achieve a significance level of 0.01, thus the statistical power will actually go down if we reduce the statistical significance from 0.05 to 0.01. This question has a sample size of 100,000 children. Now, because the sample size is so very high, we cannot safely say that we have actually found a correlation between blood sugar and IQ, even though the p-value is very small. P-values tend to become smaller as we increase the sample size. So we should find out the actual size of the effect before we make any strong statements of the correlation between blood sugar and IQ. In this case, we had researchers who ran 50 statistical tests, and we would expect to get at least 2 or 3 tests which had p-values less than 0.25 just by chance. Thus, the fact that we have these 2 significant p-values isn't a very strong statement. It's just likely a reflection of chance rather than a finding of true effect. In this question, we have researchers who found that women who took a particular drug X had a significant increase in bone density, but women who took a drug Y did not have a significant increase in bone density. The correct answer here is B. The fact that the p-value is significant in one group but not the other does not tell us whether the two groups differ significantly. It also does not guarantee that the effect is bigger in the drug X group because p-values depend on the effect size, the variability, and the sample size as well. The question here has researchers who attempted to determine whether babies who are exposed to X-rays while in the womb have an increased risk of certain childhood cancers. We see that the odds ratios comes out to be 2.44. The confidence interval is 0.95 to 6.33, and the p-value is actually greater than 0.05. The failure to find statistically significant result may reflect a lack of statistical power than the lack of an effect. Thus, we should pay more attention to the effect size and confidence interval rather than to the p-value. Both myeloid leukemia and in utero X-rays are rare events. Thus, the statistical power for this association was likely to be very low. The correct answer thus turns out to be B. Out of the 5 options given in this question, the only 2 for which we have correlated observations are C and E. In C, we are comparing the pre-treatment with the post-treatment values of certain patients. And these are obviously correlated because we are looking at the same patient before and after treatment. And E has a group of cases where we were looking at sibling controls, and these again would tend to be correlated because the siblings would share some genetic information.